Student friends, let me continue with fiber optic communication. That is the first topic of paper number 16. In yesterday's lecture, we studied the meaning of optical fiber communication, then meaning of optical fiber. What is optical fiber? That we have covered. Then we have studied need of light to carry the signal from transmitter toward the receiver through the optical fibers. Why light is needed. Then we have studied the working principle of optical fiber, where we have studied that optical fiber is a waveguide. Obviously, it is a cylindrical waveguide that contains core and cladding. In which the light radiations are guided along the axis or parallel to the axis due to the total internal reflection provided. The refractive index of the core should be greater than that of refractive index of the cladding, and angle of incidence will be greater than that of critical angle at the boundary to the normal. Thus, we concluded that fiber optical communication takes place due to total internal reflection that is taking place within the fiber. After that, we have studied the applications of optical fiber. What are the areas where the optical fibers are being used? Almost now we have covered 11 areas. Dear friends, today we are going to study some of the definitions which are being used to study the optical fiber communication. Yesterday only you are made familiar with these terms, that is the bit rate, baud rate, bandwidth, channel width, power calculation in the optical fiber. So these are the few terms which we want to define it. That helps to study the optical fiber communication. The first term which we are going to define, and that is the bit rate. Dear friends, we are well aware that bit is the short form of writing the binary digit, which was studied in B.Sc first year in the digital electronics paper. Bit rate means the number of bits which are transmitted from transmitter to the receiver per second. That is called as a bit rate. Or the rate with which bits are transmitted or received is known as bit rate. It is bits per second. Bit rate represents the speed of data. Once we know the bit rate, definitely we can get the idea about the speed with which the data is transmitting or it is going to be received. Mathematically, it is defined as it is a reciprocal of the bit period. That is, bit rate is equal to 1 upon bit period, that is TB. TB is the bit period. Bit period means time required to transmit the one bit. Maybe it is 0 or it may be a 1. So its reciprocal is going to give us the bit rate. For example, if the bit deviation period is 2 milliseconds, it is an example. Time required to transmit the one bit from transmitter to the receiver, it is a 2 millisecond. Then bit rate is its reciprocal, means 1 upon 2 millisecond. So that is 1 upon 2 into 10 raised to minus 3, and that becomes 1000 upon 2, that comes to be 50 bits per second. Means in 1 second 500 bits are going to be transmitted. This is the example. Student friends, do remember that there may be objective questions which are likely to be appearing on this particular aspect. Maybe bit rate is given, bit period is expected to be calculated, or reverse. Then second term we have to define, and that is baud rate. It is a signaling elements or symbols which is transmitted or received within a given unit of time. If the signaling elements are 0 and 1, the baud rate is in bits per second or multiple of bits per second. Especially these are terms which are used for the digital data communication. Increase in signal representation level increases the baud rate. Dear students, you might be studied or going to study in the microcontroller paper that whenever the serial communication is to be performed between the two computers or between one of the device with the computer, while writing the software, you have to define the baud rate. So that will help to communicate serially with the data rate. Next term we are going to define, and that is the bandwidth. Friends, bandwidth we are aware. The amount of data to be transmitted is proportional to the bandwidth and time of the transmission. That means how much amount of the data is transmitted within a given width or within a given interval of transmission time. That is called as a bandwidth. Generally, we are well aware that it is the difference between upper cutoff frequency and lower cutoff frequency. Within that band, how much amount of data is to be transmitted, that is called as bandwidth, as far as optical fiber communication is being considered. Naturally, if bandwidth is more information is going to be transmitted within a given interval of time. It is quite obvious. For example, we have studied in the telephone communication. Whenever a voice signal is transmitted, it is transmitted within a bandwidth of 3 kilohertz. In the semester 5th, we have studied all these things. In television communication, we studied that video signal requires 4 megahertz bandwidth. So voice signal 3 megahertz, video signal 4 megahertz. Total audio and video signal bandwidth is 7 megahertz. So that's how we can understand the meaning of bandwidth. Then friends, next term is the channel capacity. Channel capacity is expressed in, it is also expressed in bits per second. It is twice the bandwidth. Channel capacity is twice the bandwidth. That is C. If it represents the channel capacity, then that is equal to given by 2 times BW, that is 2 times bandwidth. If the channel capacity is 100 bits per second, then bandwidth is C by 2, that is 1000. If the channel capacity is 1000 bits per second, then bandwidth is C upon 2, that is 1000 upon 2, that is 500 hertz. reverse is also true. All these are required to transmit the data in the optical fiber from transmitter to the receiver with the working principle of total internal reflection. The last term which we are going to define, and that is the power calculation. In physics we have studied power of optical fiber is calculated in terms of radiance of light intensity, which is transmitted and received through the optical fiber. So radiance is the measuring aspect, which is measuring aspect of the power of the light, which is generally used, and same that is applied in the optical fiber communication also. Dear students, these are the some of the definitions which we are required to be covered. Now to proceed further, actually we are going to study now the block diagram of optical fiber communication. Friends, this diagram plays the very vital role. Please do remember this particular block diagram. If you remember this, we are elaborating this particular diagram in further lectures so as to study details of this same. Naturally, if you are remembering the general block diagram of the electronic communication, which we have studied in semester first, topic number first, that is fundamentals of communication. Please do remember that diagram. Based on that only, rest of the communication that we are going to study. With that particular consideration, we can say, naturally, only the channel is being changed. Otherwise, the rest of the things are going to be remaining same. So with that particular aspect, we can say, the block diagram of optical fiber communication includes the transmitter having the light source associated to drive circuitry. Means driving circuitry is necessary to drive the light source so as to emit the light radiations. This block we can call it as it is a transmitter, where the modulation may going to take place. One of the property of the light radiation is modulation of the light, it is possible. So that particular unit we can call it as it is the transmitter. Then a cable with mechanical and environmental protection to the optical fiber inside is the second part of the block diagram. Means a cable that connects the light source and that of receiver, which has a full mechanical and environmental protection, because the optical fibers are very, very thin. They may be located anywhere in the atmosphere. They may go into damage, and that's why the mechanical and environmental protection must be provided to that. That's why optical fibers are encapsulated within the buffer. So including that buffer and internally the fibers is called as optical fiber cable. That is used to connect the transmitter as a light source and receiver having the photo detector, amplifier and signal restorer. Means in between transmitter and receiver, a cable is connected. That cable we can call it as it is optical fiber. Thus we can say optical fiber provides the link between source and detector. For long distance communication, in addition to protecting glass fiber during the installation and service, in between that it contains the copper wire with the combination of light source and detector to power repeater needed to amplify periodically and reset the signal. Means if the distance between light source and detector is very long, and to cover that particular distance between transmitter and receiver, and to maintain the signal strength continuously to complete the successful transmission and reception, in between that optical fiber, in between transmitter and receiver, at a certain distance, the copper wire connected with a combination of light source and detector. Means incoming light radiations containing the signal will be detected. Again they are going to be converted into light source. Again it will propagate within the cable. So to boost the signal power, in between the optical fiber, the combination of source and detector is going to be used. The cable contains thin hair-like glass fiber is one independent channel. Means one hair-like glass fiber is one independent channel. That it means. So all these are we are going to study obviously with the block diagram. We can say optical fiber can be located anywhere. It may be in the air hanging, it may be in the duct, it may be under the sea area, it may be buried directly in the ground. Friends, we are, while coming to the college or while traveling on the road, on the sidewide, so many persons are working with the cable. There is a big round cable, those are burying in the ground, that contains many optical fiber thin cables. Red color, yellow color, green color, blue color. You might be observing that particular aspect. Maybe those are used for the telephone communication or even mobile communications, even internet purpose. So that's why we can say this cable may be anywhere installed in the air, maybe in the duct, or maybe in a sea underwater, or buried directly in the ground. The cable strength will depend upon the communication distance. If the distance is less, okay, no problem. If the distance is more, then two or more cables are going to be gets connected with each other by splicing technique. The actual size is determined by practical considerations like size and cable weight. Short length cables are used in axial or direct buried applications. But for long distance, the line is formed by splicing individual cables. Once the cable is installed, then light source like LED or laser diode, compatible dimensions with the optical fiber core, to launch the power into the optical fiber by changing its bias current. The light which is emitted by the LED or laser diode is going to be modulated, and it is connected to the one end of the optical fiber. The electrical signal to be transmitted is given to the light source. As the electrical signal changes, accordingly, the light radiations which are emitted from the LED or laser diode, those are modulated, and hence LED along with its driving circuitry with the modulating unit, it known as a transmitter, it converts the electrical signal into the optical power by varying the current through the source. Now obviously the source, that is LED, uses the square law. That is, linear change in input current produces linear change in optical power. Means light radiations which are coming out from the LED, which is expected to be launched to the optical fiber, it is proportional to the change in input current. Change in input current is proportional to the signal to be transmitted. Friends, these optical sources, LED, laser diode, are made up of either gallium arsenide or gallium arsenide phosphate, gallium indium arsenide phosphate. So these are the materials which are used to construct the light sources. Dear students, after launching the optical power into the fiber, it will progressively attenuated and may be destroyed with increasing distance due to scattering, absorption, dispersion in a waveguide. So that's what the definition of the optical fiber communication. In spite of scattering, absorption, dispersion, deviation, the light radiations are propagating from one end to the another end due to total internal reflection. So that's what we can call it as it is the optical fiber communication. Therefore, repeater is used to amplify and reshape the signal as we have explained just now. Repeater is a combination of source and detector which is placed back to back. Now signal is sent into receiver containing the photodetector, which also obeys the inverse square law to convert optical power into the electrical signal. And this electrical signal may be restored in the required form by using the suitable transducers. So same aspect we are going to explain with the block diagram here. So students, this is the block diagram of optical fiber communication. As I already explained that, here is the electrical input signal to be transmitted. Obviously, it may contain the conversion of the physical signal into the electrical signal, physical parameter into electrical signal. For example, if you use the mic here as a transducer, which converts acoustic sound signal into its electrical signal. Such any physical parameter may be going to be converted into the electrical signal by the suitable transducer, which is expected to be communicated from one point towards another point. So this is given to the transmitter as a beginning block of optical fiber. As I already told you that it contains the light source and its driving circuitry. As per electrical signal provided, it may be kind of a simple amplifier which is going to act as a driving circuit. It is amplified by the driving unit and then it is given to the light source as a laser diode or light emitting diode. As electrical signal changes, naturally the biasing current of light source changes. Accordingly, emitted light is going to be get modulated. This is the role of transmitter. So modulated light, converted light passes through the optical fiber. So friends, try to remember, whatever the blue said it is represented, it is the optical fiber. Everywhere, whatever the blue represented, it is the optical fiber. If suppose two or more fibers are going to be connected, then the splicers are being used. One can couple the two fibers with each other. This optical fiber is connected to the receiver. So this is the receiver block. Here already is black signal represents the electrical signal, whereas the blue represents the optical signal, that is the light radiation. Receiver contains the optical receiver. Optical receiver means a photodiode that receives the incoming light radiation and convert it into electrical signal. If that electrical signal is very weak, it is amplified by the amplifier that is going to be utilized in the electronics. So again, maybe it is a optical transmitter. So that is a combination of repeater, it is represented. Optical receiver, detector, that receives the light radiation, convert it into again electrical signal. This electrical signal is amplified, strength is improved, and again it is given to the optical transmitter, means LED. So that's what it is called as a repeater. It is being used in between. If the distance is very, very long, if the distance is less, no need of this. Again, light radiations travels, maybe it is amplified if required, then it is finally to be given to the receiver. A receiver contains a photodetector. It converts the light radiation into electrical signal. It is amplified and signal is going to be restored. Friends, once the light radiations are converted to electrical signal, it is represented by means of a dark black color. This electrical signal is amplified and then it is given to the signal restorer. For example, if the acoustic signal is a sound signal, then in the input to convert it into electrical signal, mic is used, but here is signal restorer. We can use it as a speaker that converts again electrical signal into its corresponding acoustic sound signal. Friends, whatever this entire aspect which we are being utilized, it is known as the block diagram of optical fiber communication. Dear students, I hope you understood the block diagramic representation of the optical fiber and also the few definitions we have covered in this particular topic. From the next topic, we are going to study details regarding the light source, that is LED, laser diode. We are studying the details regarding the meaning of optical fiber, types of optical fiber, how more fibers are going to be gets connected with each other, that is a splicing technique. We are also going to study details regarding the detector, that is photodiodes. We are also going to study exactly the meaning of transmitter and meaning of receiver in continuation with the further lectures. So that's why, friends, today we'll stop here only. Rest we will see in the